Good evening, children. Good evening, online students.
Good evening.
Good evening, ma'am.
Good evening. Good evening. Just help me take the sums which we have already worked from this. I think this one we've already done. It's -4. Just open your class work notebook. Which is done, -4. This one is done, right? This is done. Then louder, darling. 4 also is done. Okay, then 1 is done. 9. Okay. Eight is done. Okay. One, three, 5. Okay. That's all? Okay, thank you so much. Yes. So 1, 3, 4, 5. 1, not 2 we'll do now. So 3, 4, 5. So we have to do 2, 6, and 7. Okay. 2, 6, and 7. Yeah. Yes. Find the non-zero value of k for which the roots of the equation are real and equal. Yeah, please work. Good evening. Okay. Completed, online children?
Yes, ma'am.
Yeah. So this equation has equal roots. Equal roots, meaning the condition is the discriminant is equal to 0. B square minus 4AC is equal to 0. What is A? The coefficient of x square. B, the coefficient of x. C, constant. Be careful when you write B square, don't write B and square like this. B, this is B, B square. That's wrong. This is B. The whole of B has to be squared. And we have to find the non-zero value of K. So K is equal to 0. No, find the non-zero value of K. So K is equal to 4. So the non-zero value of K is 4. We finished all this. We have to do this, right? 7. You said 2 and 7, huh? Yeah, 2 and 7. Okay, fine. That's not wasting. Find K if the equation has coincident roots. Coincident roots meaning equal roots. Equal roots, coincident roots. Unequal roots, distinct roots. And see, when the roots are coincident, that means they're real and coincident. There is no situation like unreal and coincident. No, no. When we say coincident roots, real and coincident, real equal roots, distinct roots, real and unequal roots. Okay, so here the equation is not in the standard form. So you'll have to bring it to the standard form so that you're able to find or pick the values of A, B, and C and then proceed. Yeah, write down. Done, all of you? Online children completed?
Yes, ma'am.
Okay. Two perfect squares you said, 9 and 8. I think 7. Okay. If the roots of the equation are equal, then prove that 2b is equal to a plus c. Okay. The roots of the equation are given to be equal. Now, is the equation in the standard form? Can you see three distinct terms? Yeah. X square term, x term, constant is equal to 0. Yes, you can see the x square term and the coefficient of x square is b minus c. We can see the x term and the coefficient of x is c minus a. And yes, we can see the constant. That term without the x or x square is a constant. See, there is no x or x square here. So that's the constant. So the equation is already in the standard form because we can see three distinct terms, x square term, x term, constant. So we can write out the values of a, b, and c. Here we'll use capital A, capital B, and capital C because we already have small letters A, B, C in the equation. So we'll say capital A, capital B, and capital C. Very simple because it's given. See, the equation is in the standard form. Okay. And the condition is given that the roots are equal. If the roots are equal, that means b is equal to 0, which means b square minus 4ac is equal to 0, right? And see here. So b square minus 4ac is equal to 0. So substitute. This is b. This is b square minus 4 into a into c is equal to 0. Now what do you do with this? You'll have to expand. A minus b the whole square is a square b square 2ab. All right. Then here I've multiplied these two brackets first. You can see the 4 here. You can see the 4 here. I've multiplied these two brackets. How do you multiply? B into A, B into B, then C into A, C into B, right? Okay. So then after doing that, then I multiply 4 with all these 4 terms. So now you can see the LHS, all the terms are free. They're out of the bracket is equal to 0. Now we'll look for like terms. Are there any like terms? Yeah, minus 2AC and plus 4AC. Other than these two, no other like terms. Okay, so this one and this one becomes plus 2AC. You can see plus 2AC. So and you can also see that the terms have arranged it in some specific order here. So I've written the a square term first, then, okay, 1 minute. Now, after simplifying, you have 6 terms. Now, these two become what? These two terms become what? Plus 2AC, right? Now, how many terms do we have? 1, 2, 3, 4, 5, 6 terms. After simplifying, we have 6 terms. 6 terms. Of these 6 terms, you can see 3 perfect squares. Of these 6 terms, you can see 3 perfect squares. A square, 4b square, and c square. So this should take you to the identity x square plus y square plus z square plus 2xy plus 2yz plus 2xz is equal to x plus y plus z the whole square. Because this identity also has 6 terms. X square plus y square plus z square plus 2xy plus 2yz plus 2xz is equal to x plus y plus z the whole square. See, we have 6 terms. We have 6 terms, and of these 6 terms, 3 terms are perfect squares. X squared, y squared, z squared. 6 terms, of which 3 terms are perfect squares. So if you have an expression, with 6 terms, of which 3 are perfect squares, check if it is of this form. If it's of this form, that is, if you have the 2xy term, 2yz, and 2xz term, then if the expression satisfies the rule here, then you can write the answer as x plus y plus z the whole square. If the 6 terms satisfy this one, then you can write it as x plus y plus z the whole square. So here we have 6 terms. After simplifying, we have 6 terms, of which 3 are perfect squares. So I've just arranged the perfect squares in the order A, B, C. So you can see a square. I've written this one first, a squared. Then this plus 4b squared. Then this plus c squared. And then minus 4ab. And minus 4bc. And we simplify these two, right? So plus 2ac is equal to 0. So now using that identity, you'll have to present the terms of the form x the whole square, y the whole square, z the whole square, then 2xy, 2yz, 2xz. Now we know this, right? When you have to, all the terms are positive here. Okay, I took it away. All the terms are positive, right? All the 6 terms in the identity, they're positive. X squared plus y squared plus z squared plus 2xy plus 2yz plus 2xz. All the terms are positive, but here we have 2 negative terms. So what is common? Which letter is common? B. B is common, right? So that B term will be negative. Can you recall this from 9th standard? In the identity, all the 6 terms are positive. See the, okay, it's right here. See the identity, all the 6 terms are positive. But here we have 2 negative terms. So which is a common variable there? B, B, B. So that B term, should be negative. So now this one is, write it like this, okay? Something the whole square plus something the whole square plus something the whole square plus 2 into plus 2 into plus 2 into. Okay, so what comes in the first bracket? A. Second bracket, 2b. But we understood it should be negative, so minus 2b. Second bracket, C. Then here 2 into A into minus 2b, correct? Then in the second bracket, 2 into minus 2b into C. And in the third bracket, 2 into C into A. That's what you see here. That's what you see here. You understand what's happening? We're just trying to present the terms. We are presenting these terms in the form x the whole square plus y the whole square plus z the whole square plus 2 into x into y plus 2 into y into z plus 2 into x into z. Where x is A, y is minus 2b, and z is C. How did we get this minus? Because these 2 terms are negative. The common letter is B. So we fix a minus sign to the B term. So A square is A the whole square. 4b square is 2b the whole square, but minus 2b the whole square. What is minus 2b the whole square? Plus 4b square. And then this one is c the whole square. So this is x, this is y, and this is z. So 2 into x into y, a into minus 2b. 2 into y into z, minus 2b into c. 2 into x into z, a into c. 2 into a into c, or c into a. Now just check if you get minus 4ab. Yeah, correct. Minus 4bc, yes. And plus 2ca or ac, yes. So those 6 terms satisfy, the nature of the expression here. So this can be written as x plus y plus z the whole square. What is x? A. Okay, x plus x, which is this one, plus y, which is this one, plus z, the whole square. Correct? X, this is x plus, this is y plus z, the whole square, which is nothing but a minus 2b plus c, the whole square. So that means a minus 2b plus c is equal to 0, the whole square, like a plus b, the whole square is 0. So that means a plus b is equal to 0. Okay. So now look at what has to be proved. We have b alone on one side and a and c on the other side. So you do the same thing. A minus 2b plus c is equal to 0. So we have b alone on one side. So transpose this. So we have a plus c is equal to 2b. That means 2b is equal to a plus c. Hence proof. Right on? One children? Completed? So in the question, we have a quadratic equation whose roots are equal, given to us. Roots are equal is given to us in the question. If the roots of the equation are equal, roots are equal is given. So you know you have to work with the condition d is equal to 0, because when roots are equal, d is equal to 0. Or in other words, b square minus 4ac is equal to 0. So we have the equation ready. B square minus 4ac is equal to 0. All that we have to do is substitute for A, B, and C. In B square minus 4AC, you'll have to substitute for B, A, and C. Okay. So after that, you'll have to simplify. Then you get these not six terms, so 7 terms here. After simplifying the like terms, we have 6 terms, of which 3 are perfect squares. So this identity comes to your mind, where there are 6 terms with with 3 perfect squares. So you arrange the terms in that order. There are 6 terms here, and you arrange the terms in this order. What order? The 3 perfect squares, and then the remaining 3 terms. In the order A, B, C, A, B, B, C, A, C. And then you present it in that form. You present the 6 terms in this form. In this form, x the whole square, y the whole square, z the whole square is this and this. And you verify. You multiply this and check, yes, you're getting this. When you multiply this, yes, you're getting this. And when you multiply this, yes, you're getting this. And why did we fix a minus here? Because all the terms here are positive. All the terms here in the identity are positive. But here we have 2 negative terms. We have 2 negative terms. And B is common. So to that B term, which is 2B, we fix the minus sign. Don't put the minus here, inside the bracket. So since it satisfies, the result is x plus y plus z the whole square. Yeah, then after this, you'll have to look at what you have to prove. B alone on one side, A plus C on the other side. So transpose and show the result. If the roots of the equation are again equal, prove that A by B is equal to C by D. Okay, we'll work this together. I think I have the answer. Yeah. So what's the value of A? Don't work, we'll do it together. What's the value of A? Correct? B, C. We see the x square term, x term and the constant. Correct? Coefficient of x square is A, coefficient of x is B, and the constant is C. Now this equation has equal roots. That means D is equal to 0, or B square minus 4AC is equal to 0. So B square, write B. What is B? 2 into AC plus BD. This is B. Square. So from the start to the end, bracket, square, minus 4 into A. This is A. This is A. Sorry? Oh, yeah, mine. I didn't notice. Sorry. Thank you. Sorry. Yeah, B is minus 2 of AC plus BD. I'm so sorry. Yeah. Minus. Correct? So minus 4 into A into C is equal to 0. This is equal to 0. All right. So now this will be minus 2 squared is 4. Then after this, AC plus BD whole square. Correct? Minus 4 into this one is equal to 0. Now you can divide by 4 throughout, because you have this term has a 4, this term also has a 4. So divide by 4 throughout. Divide by 4 throughout. 4 and 4 cancels, 4 and 4 cancels. This one also by 4. So then you will have AC plus BD the whole square minus a square plus b square into c square plus d square is equal to 0. So then on simplifying, you have opened the bracket and then I've divided. Oh, I don't want to do this. No, I thought I'll present the answer which I've got there, but there I've expanded and I don't want to expand. I think now you can start working with me. Okay, so after this, AC plus BD the whole square. So it will be AC the whole square plus BD the whole square plus 2 into AC into BD. Then minus A square into C square plus D square plus B square into C square plus D square is equal to 0. Should I wait? Anybody still writing? Here, all of you finished till here? Can I switch to the next slide? Online children?
Yes, ma'am.
'Okay. 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 ' So AC plus BD the whole square is AC the whole square plus BD the whole square plus 2 into AC into BD minus, see here, there's a minus sign and there's a product here. This minus sign is for all the terms in the product. So see the bracket minus, we're going to multiply the two brackets. Everybody has a minus sign. So I've used the square brackets. Can you see? Minus and in square bracket, we're performing the multiplication. So here it will be a square c squared plus b square d squared plus 2abcd minus a square c square plus a square d square plus b square c square plus b square d square is equal to 0. On opening the bracket, a square c square plus b square d square plus 2abcd minus a square c square minus a square d square minus b square c square minus b square d square is equal to 0. So now cancel, 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 cancel. That's all. Okay, so now we have three terms. Again, so minus a square d square plus, add anything first, but minus b squared c squared plus 2abcd is equal to 0. Change the signs throughout. Change the signs throughout. So you have a square d squared plus b square c square minus 2abcd is equal to 0. Change the signs throughout. Write the opposite signs. Minus plus. So it's plus minus. Now this is x the whole square plus y the whole square minus 2 into x into y is equal to 0. Three terms with two perfect squares, no? There are three terms with two perfect squares. A square, d square, and b square, c square are two perfect squares. So there are three terms with two perfect squares. So it may be x squared plus y squared. Not here, it can be x squared plus y squared minus 2xy. So we'll just see. Okay. So this is AD the whole square, BC the whole square, minus 2 into AD into BC. Check. Yeah, minus 2abcd, correct. So this is nothing but AD minus BC the whole square is equal to 0. Because it's minus 2ab or minus 2xy. So this means AD minus BC is equal to 0. So AD is equal to BC. What do we have to prove? A by B is equal to C by D. We have to prove that A by B is equal to C by D. Okay, so bring this B for division. Do it one by one. Bring this B for division. We know AD is equal to BC. Now bring, see, it's A by B, no? So bring this B down. So AD by B is equal to C, correct? Then it's C by D. So bring this D down to the other side. So we have A by B is equal to C. Bring this D to the other side, C by D. You can do it in one step also. You can do it in one step also. Show you again. We have AD is equal to BC. See the result A by B. There's B here, no? So AD by B is equal to C. Then it's C by D. So take the C D to the other side. So A by B is equal to C by D. Is right on. Completed, all of you? Online children?
Yes, ma'am.
Okay. So the equation c squared minus ab into x squared minus 2 into a squared minus bc into x plus b squared minus ac is equal to 0. What's a? What's the value of a? C squared minus ab. B minus 2 into a square minus bc. And c is b squared minus ac. The rest of it, everything other than the x and x squared terms. B squared minus AC. Okay. So this equation where ABC has equal roots. This equation has equal roots. Is given. Therefore, D is equal to 0 or B squared minus 4AC is equal to 0. B squared. This is B. This is B squared minus 4 into A. This is A and this is C is equal to 0. Correct? What is minus 2 the whole squared? 4 into a square minus b square the whole square. Sorry, a square minus bc the whole square minus 4 into c square minus ab into b square minus ac is equal to 0. I will not expand or multiply. We'll divide by 4 throughout. Okay, so 4 into a square minus bc the whole square divided by 4 minus 4 into c squared minus ab into b squared minus ac divided by 4 is equal to 0 by 4. Please write down till here. And then like we did in the earlier one, please open the expand, open the brackets and tell me the terms you get. After that, we'll continue together. So after this, we have to expand a square minus bc the whole square. All right. So like x minus y the whole square, x squared plus y squared minus 2xy. Here, keep the minus sign outside. And inside the square brackets, find this product. C square into b square minus ac minus ab into b square minus ac. So we're finding the product, but please use a square bracket because the minus outside is applicable to every term you get in this product. And so when you open, when the brackets are released, you have 4 terms here. And when you release this bracket, you can see the signs changes, the sign changes. Plus b square c squared minus b square c squared cancels. And we have 2 like terms, a square bc minus 2 minus 1. So minus 3 a squared bc. So now I just looked at the 4 terms available and I arranged them in this order. A to the power 4 we have, then ac cubed, ab cubed. So I put a to the power 4 first, and then ab cubed, ac cubed, and then these two make minus 3 a squared bc is equal to 0. I wrote this one first, then I wrote this ab cubed, then ac cubed, b cubed, c cubed. Because I thought this is a into b cubed, right? This is a into c cubed. Then what is this? A into a cubed, right? This is a into a cubed. This is a into b cubed. This is a into c cubed. So I wrote it in that order. This is a into a cubed, a into b cubed, a into c cubed. And then when you simplify these two, we have minus 3 a squared bc is equal to 0. Now in algebra, whenever we have in an expression, whenever there's a common factor, we take out the common factor. Now these 4 terms have a in common. These 4 terms have a in common. Whenever there's something common, you have to take out the common factor. So a is common. All the 4 terms have a in common. So take out a. So that makes a cube plus b cube plus c cube minus 3abc in the bracket is equal to 0. Now when a product is 0, like when you have x minus 4 into 2x minus 1 is equal to 0. When a product is 0, how do you continue? X minus 4 is equal to 0. X is equal to 4. Or 2x minus 1 is equal to 0. X is equal to 1 by 2. In the same way here, this product is 0. A into a cube plus b cube plus c cube minus 3abc. It's a product, it's 0. So that means a is 0 or this one is 0. Like a bracket. This product is 0. So either this is 0 or this is 0. So when you work this, you'll have to check what we have to prove. We'll have to show that a is 0 or a cube plus b cube plus c cube is 3abc. Okay. So take this to the other side. Hence proof. All right. Online children, any questions? Finished? Any questions? Finished? Online children, use the emoji, raise your hand. So Hari Pranav, Niveda, Roshni, Blessy, Pratish, Prenu, Mritsa, Aragamai, Sabarnan, Sadhna, Anugraha, Srivatsan, Hasif. Aniruddhan, are you there? Okay, Aniruddhan. Okay. Okay, completed online children. Shall we go to the next one?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Try to do this by yourself. Equations are different, but the condition is the same. All have equal roots. Okay, so as you approach the last step, you should see like what we have to prove. We'll have to prove that c square is equal to a square into 1 plus m square. That means they are having the c square term on one side. C square is on one side, a square and m square on the other side. So a square plus a square m square is equal to c square. You can write it like this. See, we have three terms, no remaining 1, 2, 3 terms remaining is equal to 0. Now, after this, how to proceed? Look at the result which we have to prove. We have c square alone on one side. So we'll take c square to one side. Then you can see the result a square and m square is on the other side. So I've taken c square to the other side. So minus c square is plus c square on the RHS. And then this a square and plus a square m square. So whenever there's something common, take out the common factor. 1 plus m square is equal to c square, or c square is equal to a square into 1 plus m square. Correct? And so you see that everywhere the equation is different, but the working procedure is almost the same, except that we've used different identities. We here in this one, no identity. But one thing is, whenever there's something common, we'll have to take out the common factor. And in this one, see, everywhere there is 4. We divide by 4 throughout. Here also a was common, so we had to take out the common factor. No identity was used here. In this one also, identity, this is always there. X plus y the whole square, x minus y the whole square is always there. Yeah, in the first one, we made use of that identity x squared plus y squared plus z squared plus 2xy plus 2yz plus 2xz is x plus y plus z the whole square. I think till here I had presented for a long time. No. Okay, if you need to check your steps, please see. Again, the important thing is this minus and this product here. This product. So please use a square. This minus is for all the terms you're going to get in this product. So that's why minus, and that product, please find inside the square bracket. So that when you get all the terms, you apply the minus sign to every term inside the bracket, and otherwise you will not get the result. Okay. Finished, all of you? Online children?
Yes, ma'am.
Okay. Yes, ma'am.
All right. So this year quadratic formula has been removed, right? Yeah, I think how do you learn how to like solve quadratic equations by using the quadratic formula? Yeah. Oh, sorry. Completing the square method. I made a mistake. Actually, I was asking myself, right, completing the square method. That is no longer a part of your syllabus. I, it's just asking that. Ignore the first question. Do the second one. And Bhavisha, just see if this -4 is the same question we did earlier, then we'll not do it again. No, it's different. You sure? Okay, then we'll do 2, 3. We're doing this, right? Completed? Yeah. What are the values of x? 2 by 3 and minus 4 root 3. Minus into minus plus 8 4s are 32. 32 into 3, 96. Rationalize the denominator. So we have 2 root 3 by 3 or minus 4 root 3. After, please rationalize the denominator. X is equal to 2 root 3 by 3 or x is equal to minus 4 root 3. Mostly I find these separately. So it's easy to, like, in case we feel we're not getting the right answer, it's easy to check. So I always find D separately. So D is B square minus 4AC. That's 196. Then X is equal to minus B plus or minus root B square minus 4AC, right? So it's root D by 2A. Here, all of you finished? You went wrong, Shakti? You corrected your mistake? Okay. Should I wait for anyone online? Okay. You have to tell me correctly. This is not done, no? Yeah, there's the next question. I want all of you to get the value of K correct. All of you. Got the value of k? Got it, Shakti? Kamalika? What's the value of p, Kamalika? Minus 2. Is the value of p minus 2? Okay.
Completed, ma'am.
Yeah, Prenu, very good. Yeah. What's the value of p?
Ma'am, P is minus 2.
And the value or values for k?
Ma'am, K is 2 or K is minus 10 by 9.
Okay. 2 or 10 by 9. Minus 10 by 9, is it?
Yes, ma'am.
What's the equation you've got? Quadratic equation?
X square minus 2x. Quadratic equation, ma'am.
Yeah. You'll get a quadratic equation on k, right? What's that equation? Oh, you've got two
9.
values for k, right?
K minus.
Yeah, then you will have a quadratic equation, right?
Yes, ma'am. That is 9k square minus 8k minus 20.
Correct. Correct. You're right, Prenu. Very good. 2 or minus 10 by 9. Very good. Value of k, 2 or minus 10 by 9. No? Here, Bhavashya and others. Online children. Meaning you've got the quadratic equation solved for k, but getting different values, is it? Okay. Getting different values. Okay, then check your mistake. So the first thing is minus 4 is the root of this equation. That means minus 4 the whole square plus 2 into minus 4 plus 4p is equal to 0, because the root will satisfy the equation. A root will satisfy the equation. So wherever there is x, use minus 4, and you can work this and find the value of p. So that's the first step. So you get the value of p. So you can use that value of p here. P, what is that? 2, minus 2. Minus 2. So you can replace p with minus 2 here. Correct? Okay. And then the second equation, there are two equations. For this equation, minus 4 is a root. For this equation, minus 4 is a root. Now for this equation, minus 4 is not a root. For this equation, minus 4 is a root, so you found the value of p. Now for this equation, you can use this p value. You can put the value of p because same letter, no? Same question, same letter. So you can use the value of p. But what is the condition for this quadratic equation? It's a perfect square. If it's a perfect square, the roots are real and equal. That means the discriminant is equal to 0. For a perfect square, d is equal to 0. Yeah. Yeah, please see. Take your steps. Yeah, I want to know where each of you have gone wrong. Starting with the Jaivarshini. Loud Jaivarshini. You know? Second equation, x is minus 4. வீட்லயும் உள்ள ஜென்ட்லா தான் பேசுறீங்களா? இல்ல இல்ல அதான் சொல்லுங்க. இது வந்து p is equal to minus 2 வந்துருச்சு. அதுக்கப்புறம் நீங்க minus 2 போட்டீங்களா? Second equation, x value is substitute to the same minus 2. Why? Oh my god, நீங்க அப்படின்னா நீங்க கொஸ்டினே கரெக்டா பண்ணிக்கலாம்னு அர்த்தம். Minus 4 is a root of only this equation, right? Minus 4 is a root of this equation. So அதை நீங்க work பண்ணிட்டீங்க. P is equal to minus 2. மறுபடியும் எங்க கொடுத்திருக்கு? Minus 4 is a root of this equation. எங்க கொடுத்திருக்கு? Minus 4 is a root of this equation. எங்க கொடுத்திருக்கு? No. Minus 4 is the root of this equation. So with the help of that information, you found the value of p. That's over. Minus 2. Now, and the p minus 2 இங்க போட்டுக்கலாம். இப்போ இந்த ஈக்குவேஷனுக்கு என்ன கண்டிஷன் கொடுத்திருக்கு? That it's a perfect square. இந்த கொஸ்டின்ல எவ்வளவு ஈக்குவேஷன்ஸ் இருக்கு? ரெண்டு ஈக்குவேஷன்ஸ். ரெண்டு quadratic equation. For each equation, different information is given. For the first equation, minus 4 is a root. For the second equation, minus 4 is not a root. The second equation is a perfect square. So for the second equation, d is equal to 0. Done. Yes, come here. அதாவது இட்லி சட்னி பூரி சோலை வச்சா நீங்க இட்லியை சோலையோட சாப்பிட்டு பூரிய சட்னியோட சாப்பிடுறீங்க. இது மைனஸ் வந்துச்சு.
minus 2 into plus 6k for the equation.
இதுதான் இந்த இதுலதான் நம்ம that's why I always, you know, like wherever there's a minus, I keep talking about the minus sign. See, minus போட்டிருக்கீங்க. இந்த உள்ள மல்டிபிள் பண்ணிருக்கீங்க. minus 2 கரெக்டா தானே போட்டிருக்கீங்க. Oh,
so equation.
Yeah, others there, Shakti, come one by one. minus 2. Instead of 9. Oh, equation வரைக்கும் வந்துச்சா உங்களுக்கு? அப்புறம் 2 into minus 8 instead of 9. Oh. Oh, okay. So that's a mistake. Okay. Minus 4. இல்ல சாஃப்டா பேசினா எனக்கு பயமா இருக்கு. எனக்கு தான் காது கேட்குது. ஓ, இப்போ ஓவர் ரைட் பண்ணிருக்கீங்களா? அதானே பார்த்தேன். ஓகே ஓகே. பட் நீங்க கரெக்ட் பண்ணதும் கரெக்டா கரெக்ட் பண்ணலையே. இஸ் வெரி இம்பார்ட்டன்ட் கொஸ்டின். ஸோ I didn't need to. Yeah. எக்ஸ் தவிர எல்லாமே பி தான். வேணும்னு சொல்றீங்க. நீங்க சொல்லு. பீனா என்ன? எக்ஸ் தவிர எல்லாமே பி தான். இல்லம்மா, எப்பயுமே அந்த எக்ஸ் டேர்ம்ல எக்ஸ கவர் பண்ணிடுங்க. மிச்சம் எல்லாமே பி. எக்ஸ் டேர்ம் இருக்குல்ல, அதுல எக்ஸ கவர் பண்ணிட்டா மிச்சம் எல்லாமே பி தான். Is it blended? Yes, Krishna Prem. Dividing? அதனால என்ன? அங்க you went from there you went wrong, is it? Okay. See, those who want, please listen. If you've understood clearly, you can continue working. If you are not sure about the answer, please listen to me. Minus 4 is a root of this equation. There is this quadratic equation which has minus 4 as a root. Minus 4 is not a root of this equation. It's not given. How can we take it like that? Minus 4 is a root of this equation, not this equation. So if minus 4 is a root of this equation, in this equation, wherever there is x, you should use minus 4. Wherever there is x, use minus 4. And so for x, if you put minus 4, you can find the value of p. You can find the value of p. In place of x, if you use minus 4, you can find the value of p. That's about this information. That's over. Now you have the value of p. Okay, what is given for the second quadratic equation? It's a perfect square. That's all is given. It's a perfect square. The second quadratic equation is a perfect square. So the second one, we have to work with the condition d is equal to 0. Because of the perfect square, d is equal to 0. So this is the second equation. But you can use this value of p minus 2. So here, instead of p minus 2, so you see here x square, then this plus sign, then instead of p minus 2, then this x, and then 1 plus 3k, all this is equal to 0. Okay, so now what is it? You just see how I've written. I put this x here. Can you see that? And this is the x term. Cover this x. This is b. 1 minute. So this is x squared. I put this x behind here. I put this x here. So plus into minus is minus. minus into plus or plus into minus is minus. Then this 2 is here. This 1 plus 3k is here. Okay, x squared. This x is out here. And minus into plus is minus 2. And then this 1 plus 3k. This one as it is equal to 0. Now, it's given that this is a perfect square. So d is equal to 0 or b square minus 4ac is equal to 0. Now, what's the value of a? 1. What's the value of b? What's the value of b? Minus 2 into 1 plus 3k. Take away this x. The rest of it is b. Take away x squared. So 1, a is 1. Take away this x. This is b. Minus 2 into 1 plus 3k is b. And c is everything else. Meaning, this is the term that does not have x or x squared. That entire thing is a constant, c. Now, see, if you have this question, why you're not opening the bracket and all that, certain equations, we open the bracket. I think the earlier presentation. One minute. See, now in this question, now here we have to open the bracket. We have to open this bracket. Why? Because this bracket has x square and x terms there. So we cannot see here. There should be 3 terms. One x square term, one x term, and a constant. Constant means, how do you identify a constant? It should not have x or x square in it. If the terms here don't have an x or x square, then that's the constant. Three terms. First term should be an x square term. Second term, x term. The third term should not have x square or x. So that's the constant. Now look at this equation. 5x squared minus 4x plus 2 plus k into. Now if you say a is 5 and b is minus 4 and the rest of it is c, that is k 4x squared minus 2x. If you say this is the x square term, so a is 5. This is the x term, so b is minus 4. And everything else is the constant. C is equal to, what is that, 2 plus k into 4x square minus 2x minus 1. You're wrong. The C, see the constant or C cannot have x square or x in it. C can have any letter, A, B, it can have A, B, C, D, whatever it can have. But it cannot have the variable x square or x in it. Do we understand that? So we have to open this bracket here. We have to open this bracket. I think we did this in the last class. We have done the sum. We have very much done the sum. I know very well. Yeah, we have done this. Last class, we took up this question. So here you have to open the bracket 5x squared minus 4x plus 2 plus 4kx squared minus 2kx minus k is equal to 0. You have to open the bracket. And then 5x squared plus 4kx squared minus 4x minus 2kx plus 2 minus k is equal to 0. You will have to group the x square terms, group the x terms, and group the terms that don't have x or x square. Now there should be only one x square. There you can see 2 x squares here. No. There should be only one x square. Take out the x square common. And in the bracket, 5 plus 4k. Okay, so here also, only one x should be there. One x should be here. Outside here, you put a plus sign, minus sign. Accordingly, you should write the signs in the bracket. I'll tell you both. Supposing you put a plus sign here, you're not wrong. You can take plus or minus. See, these two terms have x common, no? So take note x. If a doubt, இங்க plus போடணுமா இல்ல minus போடணுமா எது வேணாலும் போடுங்க. இங்க plus போட்டீங்கன்னா என்ன ப்ராடக்ட் வரணும் உங்களுக்கு minus 4x ன்னு வரணும். அப்ப இங்க என்ன போட்டா minus 4x வரும்? minus 4 போடணும்ல? அப்பதானே minus 4 into x minus 4x ன்னு வரும். அவ்வளவுதான். அப்புறம் அடுத்த ப்ராடக்ட் வந்து உங்களுக்கு minus 2k x வரணும். இங்க x மட்டும் தான் வெளியில இருக்கு. அப்ப இங்க என்ன பண்ணணும் minus 2k போட்டாதானே minus 2k x வரும் ப்ராடக்ட். ஸோ இது நீங்க பிளஸ் சைன் போட்டீங்கன்னா இப்படி வரும் பிராக்கெட் குள்ள. இங்க நீங்க மைனஸ் போட்டீங்கன்னா போடுங்க எது வேணாலும் போடுங்க. யூ டேக் வாட் எவர் சைன் யூ வாண்ட். இஃப் யூ புட் minus here, then minus 4 into x is minus 4x. Then don't put minus here. Then minus into plus is minus. So plus into minus, minus 2kx. So outside here, you can take a minus, you can take a plus. Accordingly, the signs in the bracket will change, but that's not going to alter the answer. You will get the same correct answer. And then plus 2 minus k is equal to 0. Now, in this situation, we had to open the bracket because we had x square and x in a different, in a different, meaning we had x square and x in more than one place. So we had to open the bracket here, correct? But in this one, yeah, this one, no? What's the question, children? This one, no? Okay, so but here, why didn't we? ஒரு இடத்துல open பண்றீங்க bracket, ஒரு இடத்துல open பண்றது இல்ல, because see here. இங்க எதுக்கு open பண்ணும் bracket? இங்க பாருங்க, இங்க x square இருக்கு. இது first term இங்க x square இருக்கு. இங்க x இருக்கு. இங்க x square ஒண்ணுமே இல்லையே. Open பண்ண வேண்டாம் bracket. So what you can x square plus p into 1 plus 3k of x it is plus 7 into 3 plus 2k is equal to 0. See here, there's only one x square term. So a is 1. Okay. And this is the x term. Is a noise coming from my mobile phone there or outside? Okay. Okay. So this is the x term. See, put this x here behind. Put this x behind here. So now cover the x. Rest of it is b. B is equal to what? Kamlika. P into 1 plus. Of course, we found the value of p. We are going to put the value of p. I'm just telling you. So b is p into 1 plus 3k. Then what is c? 7 into 3 plus 2k. Why we didn't open the bracket here? Because we have x square in only one term. We have x in only one term. And that last term does not have x or x square in it. It has k. Let it have anything. It does not have x or x square. See here. See again. This first term has x square. The second term has x. The last term does not have x or x square. So x square is in one term. X is in one term. And the last term, no x, no x square. Then don't open the bracket. Okay. From where is that noise coming? No, it's from the street, I think, right? Okay. Yeah. So I've taken the value of p minus 2 here, plus into minus. So we don't have to open the bracket. Plus into minus as minus. I put this x behind here. 1 plus 3k, and this one as it is equal to 0. Don't open the bracket. So get the values of a, b, and c. Then it's a perfect square, which means d is equal to 0, which means b squared minus 4 into a into c is equal to 0. Yeah, the rest of it is familiar to you. So இது வந்து ஒரு 2-3 questions of the same type பண்ணியும் I think Prenu got the answer, but others somewhere we were struck, somewhere we went wrong, either with a sign or not identifying ABC properly or unnecessarily removing the bracket. Okay. No, you can still ask me if you have a question, you can ask me. If I'm not clear anywhere, please ask me, children. Complete this one, all of you. Yeah, online children. Important in the sense, these are most frequently asked questions from quadratic equations. Okay. Let's do this one. Solve for x using the quadratic formula. Quickly, 5 minutes we have. Let's try to finish this in 5 minutes. Solve for x using the quadratic formula. Take up this A question. Oh, you want the question? Oh, sorry. Yeah, this one. Done? Yeah.
Completed.
Yeah, just a second. Okay. Now we'll solve this, like in the usual method, like if no, condition is given to you, like here the heading is solve for x by using the quadratic formula. If nothing is mentioned, then how would you solve it? So you can just open the bracket. So x squared minus root 3x minus x plus root 3 is equal to 0. So group the first two terms, group the last two terms, x common, x minus root 3 minus 1 common. So x minus into minus is plus root 3 is equal to 0. So x minus root 3 into x minus 1 is equal to 0. So x is equal to root 3 or x is equal to 1. Simple. Okay. But now we are instructed to solve for x by using the quadratic formula. Then we cannot do that. So x square minus 1 of x plus root 3 is equal to 0. So what's the value of a? 1. B minus of root 3 plus 1 and C root 3. Now let's find D. B square minus 4AC. B square minus root 3 plus 1. B square minus 4 into A into C. Correct? B square minus 4AC. So this is minus into minus plus. So root 3 plus 1, the whole square minus 4 root 3. Now this is of the form A plus B the whole square. This is of the form A plus B the whole square minus 4AB. So see here, let me not write this as 4 root 3. We'll have it as 4 into 1 into root 3. Can you see? A plus B the whole square minus 4 into, okay, you can write it as root 3 into 1. Four into A into B. What is A plus B the whole square minus 4AB? What's the identity? A plus B the whole squared minus A minus B the whole squared is equal to 4AB. So A plus B the whole squared minus 4AB is equal to A minus B the whole squared. A plus B the whole squared minus 4AB is equal to A minus B the whole square. So root 3 minus 1 the whole square. You will not be able to get this if you expanded it. If you expand it, I think you will get two terms, which will not be a perfect square. You will get two terms, right? Did you get two terms? Some root 3 term and one constant root apart. Yes or no? Yeah, you cannot. You can, I'll tell you the next class. You remind me, I'll tell you what you should do. You should use the identity. For now, that's all I can say. Otherwise, you should not add 3 and 1 children. Okay, you had the 3 plus 1. No, you should not add 3 and 1. You should have 3 and 1 separately and that plus minus 4 root 3. Sorry, this is, yeah. So you would have got 3, 1 and 4 root 3, right? You should not add 3 and 1. You should have 3 as 3 and 1 as 1. You should write 3 as root 3 the whole square. 1 as 1 the whole square. So then that middle term you'll have 2AB, 2 into root 3 into. What are the terms you have? 4 minus 2 root 3, is it? 4 minus 2 root 3, correct? You should not have, so you should have 3 and 1 separately, like 3 plus 1 you should not add. So 3 plus 1 is 3 plus 1. 3 is root 3 the whole square. 1 is 1 the whole square. And then you have the 2 root 3, no? That is 2 into A into B, 2 into root 3 into 1. That will give you A minus B the whole square. But now how would we know that? We'll add 3 and 1, no? 3 plus 1, 4. So you will have 4 minus 2 root 3. So then you cannot find the roots. Okay, so A plus B the whole squared minus 4AB is A minus B the whole square. Agree all of you? Yeah, now X is equal to minus B plus or minus x is equal to minus b plus or minus root d by 2a minus b minus b. So minus, so it will be plus, okay? So it will be plus or minus root of d. D is what? Root 3 minus 1 the whole square. Root 3 minus 1 the whole square. Divided by 2a, 2 into 1. So it is root 3 plus 1 plus or minus root 3 minus 1 by 2. So it is x is equal to root 3 plus 1 plus root 3 minus 1 by 2, or x is equal to root 3 plus 1 minus root 3 minus 1 by 2. Let's continue here. So x is equal to, when you open the bracket, you will get 2 root 3 by 2. 2 root 3 by 2, or x is equal to 2 by 2. So x is equal to root 3, or x is equal to 1. Okay, since it's time, children, I'll share this answer on WhatsApp. Okay. All right, children. So that's it for today's session. Thank you so much. Online children can leave the call. Good night. Thank you.
Thank you, ma'am.
Thank you, children.
Mom.
Yeah, Prenu.